Al Jazeera Podcasts.
Today, can we afford a world without coral reefs?
There's 1 billion people in the world that are relying on coral reefs. And so that's a problem.
Scientists say 90% of coral may be extinct in 25 years. Conservation efforts are fighting to prove them wrong. I'm Manuel Rápalo, and this is The Take.
I have 6 people in my family right now with active cancer, and there are many cancer drugs that are derived specifically from coral reefs. And so there are quite a few reasons why anyone should care and should be part of the solution.
Awesome facts about our coral reefs. Number 1, coral is being used to try to cure cancer and a lot of other diseases. Coral is actually being used in research by scientists in all sorts of clinical trials and studies for creating medications all the way from cancer to Alzheimer's and plenty of other things. Number 2.
Hi, I'm Heather Starck. I'm the Executive Director of the Coral Reef Alliance, and I am based in Wilmington, North Carolina.
Welcome to The Take. Let's start simple. What is coral? Is it a plant? Is it an animal? Is it a rock? Is it somehow all three of these things at once?
Manny, that's a great question because it's one that we get a lot. And I will start by saying, most of all, it's an animal. So it's an animal. There are little coral polyps, but they do have a symbiotic relationship with algae, photosynthetic algae that provide them nutrients. And they also secrete, especially the hard corals, secrete calcium carbonate. And so they actually do sort of build themselves into rocks. So really, there's a component of all three, but they're an animal.
It's definitely a trick question, right? But I think that understanding more about coral is part of what helps to explain why coral is so vulnerable and why it's so complex to try to save it. How much of coral reefs has the planet lost already? I've seen headlines that suggest that in the last 75 years, more than 50% of coral has already disappeared. But how much of the world's coral reefs are already gone?
We've lost a lot in the last 40 years.
They turn white and they start to die. It looks like this. It's called bleaching, and it's already happened to about half the world's coral.
It's really hard to put an exact number on that because coral reefs are also growing and they are adapting to climate change, but it is a real problem.
Over a third of all reefs will be destroyed or seriously damaged within the next 10 years.
We could lose up to 90% of the world's coral, live coral, within the next few decades. If
we don't make significant changes, we could lose 90% of them by 2050. And of course, that's in my daughter's lifetime. That's potentially in my lifetime. And it's just the trends are going in a negative direction for sure.
Yeah, I definitely want to ask you about how dire the situation is exactly. But I want to ask you also, coral reefs are often described as the rainforests of the sea. Can you talk about why coral reefs are so important, economically, culturally, even ecologically?
Sure. And I actually really like that comparison, that they're the rainforests of the sea, because a lot of people understand what the rainforests provide to Earth, to people. And I've seen diagrams where you have 2 lungs and one side is on rainforests and the other is coral reefs. And so they actually exist in over 100 countries around the globe, and they provide food and shelter and habitat for 25%, a quarter of marine species. They're really, really, really important. But one of the things that people don't think about is the oxygen that the ocean provides. So that 2 sides of the lungs, 50% of our oxygen comes from the ocean. And so if we want a healthy atmosphere, we have to have a healthy ocean. And if we want a healthy ocean, we need healthy coral reefs.
A healthy ocean depends on a healthy reef. And 70% of our planet is ocean. So If we don't have a healthy ocean, we don't have a healthy planet.
Right.
This is a problem that for so many people is just out of sight and out of mind. It's literally under the surface of the water where most people in the world will not get to experience just because of where they live, perhaps. Why should someone who lives 1,000 or 3,000 miles away from the nearest coastline care about coral reefs?
It's one of my favorite conversations to get into with my family, my friends, a person on the airport with me. But why should you care? There's so many reasons. I mean, first of all, it's a humanitarian issue. There's 1 billion people in the world that are relying on coral reefs. And so that's a problem. The quarter of marine life, again, you can kind of pull at a heartstring of just about anyone you meet if you talk about a quarter of marine life, and 1 billion people could be severely affected by their decline.
Every morning, Kalume Kahindi sets out to sea to catch fish. Thousands of people here on Kenya's coast do the same.
You work for yourself, and you sell it as you choose. You sell to women, and they make their own money. It's benefiting everyone in this community.
The fish he catches depend on nearby coral reefs to reproduce. He doesn't make a lot of money, and if the coral goes, his livelihood goes too.
But there are other things as well. Obviously, tourism, if you like crystal clear water when you go to a beach, coral reefs are providing that. Seafood, food that you eat, they really provide for a lot of people, even if they're not on the coast. And so I can keep on with that list, but there are quite a few reasons why anyone should care and should be part of the solution.
More with Heather after the break. So, Heather, can you explain what coral bleaching is and why is it so devastating for coral reef ecosystems?
So, coral bleaching is a stress response. That's the easiest and best way to think about it.
Coral bleaching occurs when underwater temperatures are more than 1 degree warmer than their long-term average. As corals come under heat stress, they expel algae living within their tissues, draining them of their vibrant colors and eventually turning bone white.
And that stress response, the two main factors are a warming ocean temperatures and pollution. There are other things that can cause bleaching, but those are the two main drivers. And especially when we see widespread bleaching, really that is telling us that it's the ocean temperatures that are rising, because that's what's similar across all of those geographies. So what happens during that stress response is that the coral polyp expels that zooxanthellae, that photosynthetic algae, and it's part of basically just hunkering down and trying to make it through that event.
Corals are a little bit like tiny upside-down jellyfish. When the sea temperature rises, it stresses them a bit like a fever in a human being, and it causes them to spit out tiny microbes that they depend on for their survival.
And so they bleach because the zooxanthellae are what make the corals the colors that they are. And so you'll see a reef that is in a state of bleaching, you'll see it's white.
But that doesn't necessarily mean that the coral is dead. Can you talk
Correct.
about what a dead reef looks like? Could you describe that for us?
So what happens then after they expel the zooxanthellae is if the conditions change and improve fast enough, then they can actually repopulate the zooxanthellae and they can live. So that is not a death sentence, a white coral.
The fishing community of Kuruwitu has set aside this space to save struggling corals and bring them back to life.
But if the conditions don't change quick enough and it's prolonged, then what happens is there's usually they're fleshy macroalgae that come in next. And it looks like a very unhealthy situation. You wouldn't dive or see pictures of a reef like that and think, oh, this is a beautiful, healthy reef. They kind of flap around with the currents. They're really kind of furry almost looking. And it looks unhealthy. It looks unbalanced as an ecosystem. So when you get to that point as a coral reef, then you know that's an area that has actually died.
We've been hearing these warnings from scientists about the threats facing coral reefs for decades at this point. I don't want to sound alarmist, but what we're hearing from scientists is the word extinction when it comes to coral. I mean, you say that we can't let that happen. So if that's the case, if efforts are being made for coral restoration, conservation, what do the coral reefs of the future look like?
So coral reefs can adapt to climate change and the rising ocean temperatures. They are already adapting. And so we see these spots of hope.
Much of the reef here in Palau has been spared, and that's in part because of the geography of the region. Water trapped by the lushly forested limestone cliffs forms a sort of lagoon and warms in the sun. But instead of getting bleached, the coral here has adapted to these extreme conditions and remains healthy. These are so-called supercorals.
Sometimes it's coupled with something that's devastating. So for instance, we do some work in Roatan, Honduras.
And I smile when you say that, because that's very close to where I'm from my hometown of La Ceiba. You have to go through my town to get to Roatan. It's a very beautiful place with very beautiful reefs.
Yeah, and you've probably snorkeled or dove on some of these reefs. So we had, again, along with the global community, had a bleaching event on Cordelia Banks. And 80% of the corals died. And this was just within the last year or so. And so that's devastating. And so, but what the hope in the story is the 20%. The 20% that lived is now sharing their larvae, not only on that one particular reef, but around the entire Western Caribbean. And the fact that they lived and have adapted to the situation where they could survive an event like that is the hope for our future, because they are now sharing that with other reefs and build the reefs of the future. And so the most important thing that we can do is decrease local threats while they are trying to adapt. This gives them more time. It enables them the ability to thrive in the future. And some of those local threats, we know the solutions to. Corals need clean water. And so we focus on wastewater because this is an issue across coral reefs all over the globe. And it's one that actually has fairly simple solutions to fix. And so if we get that raw sewage out of the water instantly is cleaner. And then that constant state of threat and stress that the coral reefs are in lessens. So then when there's a bleaching event, they can handle it better because they're not already sort of immunocompromised.
Let's talk a little bit more about those solutions and the efforts that are already being put in place. What is coral restoration, for example? What does that mean when somebody talks about restoring a coral reef? What does that mean in actual practice?
What that means is that we are looking at how coral reefs can thrive into the future. How can they adapt?
We bring the corals to the lab and then we stress them, increase the temperature of the water that they're in, and to see which of them are surviving. And those would be our heat-tolerant corals.
We're doing some of that work and just ensuring that we can do whatever we can to help the corals get through this time of really needing to figure out how they can survive into the future. And so some of that might be a diver, going on an expedition, helping a local organization to plant fragments of corals out on a reef.
Being able to take our artificial reefs that we've designed, carry them into the water, clean those, observe, look at the health as they're growing. So it's an everyday thing. It's intensive.
Oftentimes they're innovating in ways that are similar to what we do with humans. So there's like in vitro fertilization happening.
That is such an interesting thing to me personally. I kind of want to hear you describe the genetic research that you guys are doing, because this is done during coral spawning events, which is one of the most mind-blowing things I think I've ever seen in my life. Can you describe for us what it looks like during a spawning event, and then what's required from conservationists to actually get samples to research on?
You don't know always exactly when it's going to happen. So a little bit of it is a luck of the draw. I was in Cozumel, Mexico years ago, probably 30 years ago now, when there was a spawning event. And I was just fortunate to be able to be in the water. And it is one of the craziest things you will ever see as they release their larvae. It's just like all of these, it almost looks like bubbles, but it's all of this larvae just coming out, almost like out a smokestack, right? They're just coming out of all of the corals. And then that gets picked up and taken away by the currents. Well, in order to do some of the genetic research that is needed to think about that diversity that we need to help the corals maintain themselves over time, what some folks are doing is actually taking almost, it looks like a funnel, and capturing the larvae as they come out in this big apparatus. Sometimes it's left in the ocean there and then sort of moved around and planted in other places. And sometimes it's taken back to the lab to do more research and to do some of that insemination in lab settings and then taken back out into the ocean. So really interesting new fields happening. It's just a really expensive endeavor. So we have taken genetic samples in all of the large ocean basins where there are coral reefs. And now we are actually trying to test if we can create a diversity layer. So you would basically, as a marine planner, just be able to click on that layer and understand where your genetic diversity is on your reef. And then what do you do with that? Basically, what you do with that is you make sure that you have protection in each of those areas where there's diversity so that one event won't take out an entire reef. You see this in land animals as well. When they're too similar genetically in a population, one disease, one outbreak of something can take down the entire population. So the effort to have large, diverse, connected networks of reefs is enabling that adaptation over time and also enabling that sort of genetic diversity that will help them battle really anything that comes at them.
It's going to take science.
It's going to take science.
It's going to take people power, but it's also going to take science. And that, you know what, I do want to ask you one question related to policy. I want to ask you your reaction as a marine conservationist when you see safeguards being rolled back. And I think of examples like this push that's happening globally to expand deep sea mining, to remove protections from marine protected areas like the Pacific Islands Heritage National Marine Monument, which is off the coast of Hawaii, where the Coral Reef Alliance is also doing work. What keeps you guys going as ocean conservationists at a time where efforts often seem so futile?
It's something that I talk to younger conservationists all the time about. And one of my early mentors is the one that really showed me the way in this case. And it really has to do with the long game. And as conservationists, you have to keep your eye on the fact that governments change, priorities change, but what doesn't ever change is what those coral reefs need. And what also doesn't change is the people part of it. So in order to enact any legislation, any protection, any funding, right, you usually have huge collaborations of people from governments to business to community members to scientists that all come together to make that protection happen. And that's often not the case when things are rolled back. It's a more singular effort. But what gives us hope and what gives me hope is that no one singular effort is in the long run going to beat out the will of big collaborations of everyone on the same page. And so you will have temporary setbacks. We see it over and over again. Conservation is not a linear line to effectiveness, but you take ups and downs and turns and arounds. And so we're just all really used to that. And so we're able to sort of take those hits and keep moving because the will of the whole is always stronger than the will of a few.
And that's The Take. If you enjoyed today's episode, don't forget to give it a like so more people can find it. And I'd love to hear your thoughts in the comments below. Let me know what stood out to you, or if there's anything you'd like us to dive deeper into next time. I'm always checking in, so let's keep the conversation going. See you tomorrow.